Hi, welcome to Essential IT and Security Skills. I'm Charles Redman, Master Trainer, here to guide you through the essentials that you are going to need to land the job that you are looking for. In this series, we're going to talk about essential PC skills. I'm going to walk you through everything from software to hardware. Most people know me as a cybersecurity expert. Well, I couldn't have gotten there without learning the basics first. That's what this series is going to do. And then we'll move on in some later series with some more advanced concepts and techniques. But remember, it all starts with the basics. It starts right here, the essential PC skills. You'll learn how to work with the registry, understand and observe in detail the Windows boot process, control processes and services, and we'll explore some of the Windows tools for programmers. The registry is a huge database that stores everything about your PC. It includes hardware information, network information, user preferences, file types, and application information. Every version of Windows stores the numerous registry files called hives in the System32 config folder. Technicians normally won't access the registry files directly. They use a number of tools such as registry editors to do this. Before Windows XP, Windows came with two registry editors, regedit32.exe and the much older regedit.exe. The differences were due to how the registry worked in Windows 98 versus Windows NT. By typing regedit or regedit32 at the command prompt or in the run dialog box, it's now going to bring up the same command. So let's take a look at some of the registry components. The registry is organized in a tree structure similar to the folders in the PC. Once you open up the registry editor in Windows, you will see 5 main subgroups or root keys: HKey classes root, HKey current user, HKey users, HKey local machine, and HKey current config. Here's a look at typical registry root keys, subkeys, and values. Root keys are composed of subkeys. A subkey also can have other subkeys or values. The registry editor shows only keys, root keys, and subkeys. Each of the root keys has a specific function. The HKey class's root defines the standard class objects like file types. The HKey users stores all the personalized information, and HKey current user stores the current user settings. Here's a look at the association of .pdf with Foxit Reader. And below are the PDF file settings, also telling the computer that whenever a PDF is opened, I want to use Foxit Reader. Rather than going into the registry to make this association, I can also do it by right-clicking on the properties of any file type and tell it what application I wish to use. So the root key functions, like HKey local machine, contains all the data for the system's non-user specific configurations. HKey current config defines which one is being used currently. The registry notation uses a specific path type of syntax. What this is doing is describing the location of the specific registry value. Keys and subkeys can have more than one value. So by going into the registry editor, you see I can edit the registry to move World of Warcraft to a different drive. Now, Values must have a defined type of data they store, either string values, binary values, D-word values, Q-word values. These are the main four that you need to be concerned with for the A+ certification. However, there are some other types of values, but these cover about 98%. The string value is the most flexible type of value. You can put any form of data in a string value. The binary value, these values store nothing more than long strings of ones and zeros. The D-word value is limited to exactly 32 bits, where the Q-word value is limited to exactly 64 bits. Special care should always be taken whenever you decide that you need to go in and edit the registry. Making a mistake can render the PC inoperable. To prevent these problems, you should always make a backup of the registry before you change anything. And then, after you're done editing, reboot the system and make sure that everything still works. Some of the more common reasons that you might have to go in and manually edit the registry would be like deleting auto-starting programs or removing registry keys from programs that you had previously uninstalled. The Registry Editor's export feature enables you to save either the full registry or a single root key or subkey. Remember, before editing anything in the registry, be sure to make a backup. That way, if you should need to restore that key, you can just simply right-click on the icon and then click Merge. Here's a look at my Run subkey, all the things that are running currently. And then once I make my required edits, I simply right-click on the icon and click Merge. Windows also includes a couple of command line tools to edit the registry. The most common are reg and regserv32. The reg command is a full registry editing tool. You can view registry keys and values, import and export some or all of the registry, and even compare two different versions of a registry. The regserv32 command can modify the registry in only one way: adding or registering DLLs or dynamic link library files as command components. Only the 32-bit versions of Windows have the regserv32 command. Now let's take a look at the boot process. The Windows installation creates a number of specific files and folders that the operating system needs to run the PC. Booting a Windows XP differs dramatically from booting into a Windows Vista or Windows 7. Windows XP was the last Microsoft operating system to use a very old boot process known as NTLDR or NTLoader. Windows Vista introduced the far more flexible yet complex and powerful Windows Boot Manager, or Boot MGR, which Windows 7 now uses. Windows XP distinguishes between the files that start the operating system, called the system files, and the rest of the operating system files. By default, you can find these in the Windows folder. The system files consist of three required files: the NTLDR or NTLoader, the boot INI file, the ntdetect.com, and the ntbootdd.sys. However, the boot sys file will only be present when you're using a SCSI hard drive. The Windows XP boot files consist of the ntoskrnl.exe. This is the Windows kernel. the WinNT sys32 config system file. This controls the loading of the device drivers and all associated device drivers. The boot files are not capable of booting the system, however. The system files, the NTLDR, the ntdetect.com, and the boot INI, they handle that part. The system files start the PC, and then at the end of that process, point the CPU to the location of the boot files. The CPU communicates with the NTOSKRNL, or the Windows kernel, and then the GUI will start to load. Next, let's talk about some of these system files, starting with the NTLDR, the NT loader. On system boot, the master boot record, or MFT, on the hard drive starts the NT loader program. The NT loader program then launches Windows XP to find any available OSs, which is why the NT loader program is there. The NT loader program must read the boot INI configuration file. Then the NT loader loads its own minimum system file, which enables it to read the boot INI file off the system partition. Next, we'll look at the boot INI file. This file is a text file that lists the operating systems available for the NT loader and tells the NT loader where to find the boot partition. The boot INI file has sections defined by headings enclosed in brackets. The boot INI file uses the Advanced Risk Computing naming system, or the ARC. This is designed to enable your PC to boot Windows from any hard drive available. This includes removable devices. Here's a look at a Windows XP machine with the bootloader showing a dual boot configuration. You see, I have the option of booting into Windows XP or Windows 2000 Professional. Next, we have the ntdetect.com. If the NT loader determines that you have chosen to start Windows XP, it then will boot the system into protected mode and then calls on the ntdetect.com to detect the installed hardware on the system. The NT loader then refers to the boot INI file to locate the Windows boot files. Next, all necessary and critical boot files are loaded. Once the NT loader finishes detections, it loads into the kernel as well as the HAL.dll, the registry, and some device drivers. Then it passes control to the kernel itself. The kernel completes the registry loading, initializes device drivers, and starts the winlogin.exe. This is when you will see your Windows XP logon screen. Like I said, Windows Vista and Windows 7 have a very different boot process than Windows XP. Unlike older versions of Windows, unlike Windows XP, Windows Vista and Windows 7 support both BIOS and UEFI. In a BIOS-based system, the BIOS uses the boot order to scan a hard drive for the master boot record. In a UEFI system, neither the master boot record and GUI partition, or GPT, neither the master boot record, GPT, nor the file system boot code is run. The UEFI simply loads the boot manager directly. Once told, the boot manager starts and reads data from the boot configuration data, the BCD. That contains information about the various operating systems installed on the system, as well as instructions for how to actually load them. We call that the bootstrap. Once the operating system is selected, Boot Manager loads Boot Manager then loads winload.exe. This is the point that the system is prepared. This is the point that tells the system to begin loading the operating system kernel. winload.exe loads hardware. winload.exe loads the hardware abstraction layer, the system registry, and any drivers and the drivers required for any boot devices into memory before the operating system itself takes over. Only then, once the operating system processes take over, it loads all the various processes and systems that comprise Windows. And at that point is when you see the Windows logo. Now let's take a look at some of the processes, services, and threads. In Windows, programs are executable files waiting on a mass storage device like your hard drive. When a program is started, Windows loads it into RAM. The CPU reads the processes, and the processes tell the CPU which bits of code to run and when. Windows is a multitasking operating system. It runs many processes simultaneously. Some processes are called applications, and some are called services. Applications run on screen or in the foreground. Services run in the background and perform a lot of your support tasks. The Windows Task Manager is basically the one-stop shop for anything you need to know with applications, processes, and services. There are several ways that you can access the Task Manager. Pressing Control-Shift-Escape, going to Start, Run, and typing Task MGR in the search box, or pressing Control-Alt-Delete and then selecting Task Manager. There are differing functions provided by the Task Manager between Windows XP versus Windows 7 and Windows Vista. Although they do look very similar. The Applications tab shows all the running applications on your system. This comes in handy if, for instance, an application locks up and stops responding. You can go to the Task Manager and simply right-click on that application and select End Task, and it will immediately shut that program down. The Processes tab shows you every running processes. The Processes tab shows you every running process on your computer. You can identify those processes because they're named after the executable files. And each process will have a username to identify who started that process. All processes have what's called a process identifier, or a PID. To identify a process, you use the PID, not the process name. the task manager doesn't know. However, the task manager doesn't show the PID by default. Here you see all the processes started by me in my Windows 7 Task Manager. And here are those same processes. Now you can see the PIDs associated with those processes in the same Windows 7 Task Manager. The Task Manager shows the amount of CPU time or percentage and the amount of RAM the process is using. By default, the Task Manager is only going to show you processes associated with that current users. If you want to see the processes started by all users, you'll need to click Show Processes from All Users. If you want to see processes started by all users, you'll have to click Show Processes from All Users. From here, if you select a process and click if you select a process and click the End Process button, you'll instantly end that process. If the process is an application, that application will immediately close. You can also right-click on a process and see a number of other options, like Open File Location, Debug, Dump Files, or Set Affinity. The Properties options offers options similar to Windows Explorer, The Properties option offers options similar to Windows Explorer. You can also use a popular free tool called Process Explorer that can give you information that Task Manager does not, such as the ability to see which processes depend on others. In Windows Vista and Windows 7, you can use the Services tab in the Task Manager to work with services directly. They can be stopped or started, and you can go to the associated process. The best way to work with services is to use the Services Control Panel outlet. The best way to work with services is to use the Services Control Panel applet. To open it, click the Services button at the bottom of the Services tab in the Task Manager, or go to the Control Panel, Administrative Tools, and then Services. Here's a look at my Services Control applet. and my services properties dialog box. To configure a service, right-click the service name, then the context menu. From there, the context menu enables you to start, stop, pause, resume, or restart any service. The Task Manager is a great tool for investigating how hard your RAM The Task Manager is a great tool for investigating how hard your RAM and CPU are working at any given moment. It also tells you what program is using the most CPU and RAM resources, so you can start or which can lead you to other troubleshooting steps to identify why a PC may not be working correctly. Here's a look at my Performance tab in the Task Manager. And you can see Blender.exe is using extremely high CPU. I may want to consider stopping that, depending on what the application is. The Networking and Users tab enables you to see network use at a glance and see which users' accounts are currently logged on to the local machine. It will allow you to look at network traffic activity and help you troubleshoot network performance problems, as well as the Users tab allows you to log off and the Users tab enables you to log off or log off other users if you have the proper permissions. The task list and task kill command line utilities enable you to work with tasks from the command line. The task list command enables you to view running processes on a local or remote system, whereas the task kill command will allow you to kill processes using either the name or the PID. Windows also provides you a tool called the Performance Console. It logs resource usage so you can track items such as CPU and RAM usage over time. You can find this in the MMC console by entering perfmon.msc. Or you can navigate to Start, Run, and or you can navigate to it using Start, Run, and Administrative Tools. You can access the performance console. You can access the performance console by typing start. You can access the performance You can access the performance console by going to Start Run and typing in perfmon.msc in the Run dialog box, or through the performance icon in Administrative Tools. Here's a look at what the performance icon looks like. Here's a look at what the performance console looks like. Now we'll talk about objects and counters. An object is a system component that is given a set of characteristics and can be managed by the operating system as a single entity, like a processor. The counter tracks specific information about an object. So you'll find many counters can be associated with an object. The system monitor gathers real-time data on objects such as memory, physical disk, processors, and network. It displays this data as a graph, histogram, or just a simple report. By default, the data displayed is from the set of three counters listed in the chart. By default, the data displayed is from the set of three counters listed in your text. By default, the data is displayed from the set of three counters listed in the chart in your text. The performance logs and alerts snap-in. The performance logs and alert snap-in in the MMC enables Windows to create a written record of just about anything that happens on your system. So Microsoft improved on the performance console. Microsoft improved on the performance console in Windows Vista and Windows 70. So Microsoft improved on the performance console in Windows Vista and Windows 7. Reliability and performance monitor in Windows Vista still has the complete performance console with all the objects and counters you see in Windows 7, but it adds an excellent resource overview, a reliability monitor tool, and a much more flexible way to use counters with the data collector sets and reports. The performance monitor in Windows 7 functions almost identically to the reliability and performance monitor in Windows Vista, but Microsoft pulled out the reliability tool to make the remaining tools smaller and tighter. You can start the performance information and tools applet from the control panel, or by going to Start and typing in the search bar perfmon.msc and press Enter. Here's a look at my performance information and tools. You see all the pertinent information, like what type of You see all the important information that helps me understand how well my computer is running, from the processor calculations to the graphics desktop performance, all the way to my primary hard disk data transfer rate. The Reliability and Performance Monitor in Windows Vista opens to a resource overview screen, which gives you details on the CPU, hard drive, network, and memory usage. The Performance Monitor in Windows 7 opens to a screen that displays some text about Performance Monitor and System Summary. Here's a look at the resource overview in Windows Vista. And the network bar in the resource overview. The Reliability Monitor tool gives you an overview of how the PC has behaved over time. It'll show you important events such as application or OS crashes. You can find this tool in Windows 7 as part of the Action Center by going to the Control Panel applet. Data collector sets are groupings of counters you can use to make reports. The data collector set enables you not only to choose counter objects to track, but also to schedule when you want to track them, but also to schedule when you want them to run. Now let's take a quick look at some tools for programmers. Microsoft has come up with many tools to enable programmers to share data objects. Over time, this sharing was extended so that you could share objects between computers on the network. In most all cases, sharing objects doesn't require you to do anything more than install an application that uses these features. Component services is there for those very rare times when something's either wrong or a programmer needs you to make a manual change. In order to access component services, you must make a custom MMC. Here's a look at the component services in Windows 7. Notice it is in the COM+. Notice it's under the COM Hive. ODBC, or Open Database Connectivity, is a coding standard that enables programmers to write databases and the applications that use them in a way that they can query ODBC to see how to locate and access a database without any concern about what application or operating system is being used. think of it as a translator between two worlds. The Microsoft tool to configure the ODBC is called ODBC Data Source Administrator. The Data Source Administrator enables you to create and manage entries called data source names, or DSNs. DSNs are used by ODBC aware applications. They query ODBC to find their associated database. You will rarely use Data Source Administrator unless, of course, you're making your own shared databases. There you have it. It's pretty simple. Remember, everything starts with the basics. Once you have these understood, everything gets a whole lot easier. If you have any questions or even just a comment, feel free to leave them below, and I do read each and every one of them. I'll see you next time.